Now, what if we have a function that is a composition of three functions? So like f of g of h of x. What we're going to end up with is f prime, we'll fill the inside in just a minute, times g prime, again we'll come back to that, times h prime of x. Now, what was g holding initially? H of x. So this is going to be g prime of h of x. What was f holding initially? G of h of x. F prime is then going to be holding g of h of x. And so what we have is a product of how each individual function is changing, multiplied together, and what each individual function had been holding doesn't change at all. Folks, we can just keep doing this over and over and over. If we have like 8 nested functions, then I'm going to have a product of 8 derivatives. And that's why we call it the chain rule, because you're kind of just like adding another link to the chain. And that's what we have here. We have a composition of 3 functions, y equals the sine of the square root of x, whole thing cubed. Now, we have an outside function, which is the whole thing cubed. We have a middle function, which is the sine function. And then we have an inner function, which is the square root of x. So to find this derivative, first, y prime is equal to, we're going to take the derivative of the outer function, which is an exponent, so power rule. 3 times the quantity squared, and what's inside, we'll deal with that in just a minute. The derivative of the sine function is, of course, the cosine function. What's inside? Again, we'll deal with that in just a minute. And then the derivative of the square root of x is 1 over 2 times the square root of x. Now, the cosine function was holding a square root of x. The exponent was acting on the sine, had to fix the color there, of the square root of x. I'm not going to be able to simplify here, but I can kind of rewrite it. So I'm going to write it as 3 over 2 times the square root of x times the sine squared of the square root of x times the cosine of the square root of x. I'm going to put a little dot between the sine and cosine just to make that really clear. And that's it. Next we have f of t is equal to t times the sine of pi t. And we do have a product, so I have t times the sine of pi t. But since pi t isn't just plain t, that is a composition. So sometimes folks will ask me, how do I know if I'm supposed to use a product rule or a chain rule? And I'm kind of indicating that in the little brackets that I'm putting underneath the functions. When I have t times the sine of t, well, that's a product. They're next to each other. And so that's going to require the product rule. When I'm putting one bracket inside of another one, that's where I'm going to use the chain rule. Now for the product rule, I'm going to use u is equal to t, and v is equal to the sine of pi t. Now I know that pi t isn't very interesting, but it's not just plain t, and so that's why we're going to use the chain rule. Now the derivative of u, so u prime, is equal to 1. And then the derivative of v prime is equal to, well, the derivative of the sine is the cosine. The sine was holding a pi t, so the cosine has a pi t. And then because of the chain rule, the derivative of pi t is going to come out as a coefficient, so I'm going to put pi out front. Now to use the product rule, I'm going to write down f prime of t is equal to u prime v plus u v prime. So f prime of t is equal to the sine of pi t plus pi t times the cosine of pi t. Now we have one that's going to be short and sweet. Y is equal to the cosine of ax. Y prime is equal to, well, the derivative of the cosine is the negative sine the cosine was holding ax, and now I need the derivative of ax. But wait a minute. How do I know out of a and x which is the variable and which is a constant? You may have noticed throughout math that letters towards the end of the alphabet, like T and X and Y and Z, tend to represent variables. And letters at the beginning of the alphabet, like A, B, and C, tend to represent constants. Don't ask me where it splits. It's just, I guess, context dependent. You've kind of known this, right? If you think about a quadratic equation, y is equal to ax squared plus bx plus c. I guess this is a quadratic function. You've known that like x and y are going to show up in your final equation, and a and b and c are maybe coefficients that are going to go into the quadratic formula or give you your vertex or something like that, right? So we're using that convention. That said, since my inside function is ax, its derivative is a. So my result is y prime is equal to negative a times the sine of ax.